Hello friends, in this session we will be discussing about VIs and SubVIs. The LabVIEW programs are called the virtual instruments. This is not the complete virtual instrumentation, as Ram may be the name of any person, but he is or she is not the God. Similarly, the LabVIEW programs, they are known as virtual instruments. It is not the complete virtual instrumentation, because the virtual instrumentation also require the hardware part. Like any instrument, the LabVIEW programs, they are having two parts. One is the front panel, another is the block diagram. The front panel is same as that of the front panel of any instrument, contains the controls, means certain inputs, indicators in the form of LEDs and graphs, and the block diagram, it is basically the brain of the instrument and determine how the different components of any instrument are wired. This is a typical example of a front panel of any instrument, which contains a on-off switch, a graph, a icon which represents this particular VI, and we are having a front panel toolbar where there are certain tools which we will be discussing afterwards. This is the block diagram. Corresponding to each and every component, there is one icon on the block diagram, and these icons, they are combined in one way or the other to form a typical logic. Here we are having a while structure, we are having a numeric constant, we are having a timing function, we are having certain switches, the temperature history, certain arithmetic operations, and so on. On each front panel, we are having a controls palette which contains further sub palettes which are having certain LEDs, push buttons, graphs and charts, and so on. Similarly, on the block diagram, we are having a functions palette which contains certain blocks for the analysis tool, for the input output, for the arithmetic and logical operations, and many more. There are certain tools available on the tools palette. One is the operating tool to run the VI. This is the positioning or resizing tool. This is used to select and position any particular component. Then the labeling tool, then the wiring tool, which is used to wire the two different components. We are having a scrolling tool. If we want to put up the breakpoints, then breakpoint tool is there. Then if you want to have the data at any particular point, then we are having a probing tool. We are having the color copy tool. If you want to change the color, these two tools can be used. Then on the status front panel and the block diagram, we are having this particular button is used to run the VI one time. This is for continuous run. Then we are having the abort execution. If you want to pause, then we can pause this one. This particular bulb is for execution highlighting button. It is used to highlight to see the execution of the data flow. Then we are having certain align object tools, distribute objects. If you want to reorder it, if you want to resize it, then different tools are there. Then if you want to have the step into button, step over button, step out button, all these functions, they are available on the front panel as well as on the block diagram. LabVIEW is having a unique feature of data flow programming. It is different from the normal or sequential programming. Here, whenever the data is available, that particular node will execute. It will not wait. The block diagram executes depending upon the flow of the data. Block diagram does not execute from left to right or top to bottom. Node executes when data is available to all its terminal, means this node, particular node will execute whenever this data and this data is available, and this particular node will execute when this data and this data is available, irrespective of the fact whether it is placed at this position or this position or this position or this position. Nodes supply data to all the output terminals. SubVI, it is similar to the function in C and or the subroutine in the microprocessor. Whenever any VI is used into another VI, it is known as a SubVI. The advantages of SubVI are it is modular, easy to debug, do not have to recreate the code again and again. It requires the less memory. For every VI, we are having an icon that represents to that particular VI. Similarly, we are having certain connectors which represents the input and the output data. The steps to create the VI: create a icon, create the connector, assign the terminal, save the SubVI, and insert the VI into the top level VI or another VI. This is how we can create the icon. Right click on the icon in the block diagram or the front panel. You will have this type of structure. It is just like similar to that of the paint. You can edit this particular structure as per your requirement. Create the icon and the connector. Here, if you will go here and right click, then you will be having the option to show connector. Now, whenever this type of connector is available, then you just have to select an object, click here, click outside. You will have this, the color of it will change, and you will have this particular box assigned to Xi. Similarly, for Vi, we can choose any of these boxes and we can assign the terminals to inputs and outputs. Then you just save the VI. If you want to access that particular VI, go to this point, then select a VI, choose that particular VI and drag it into the block diagram. This is how we can create the SubVI. In this lecture, we have discussed about the VIs and the SubVIs. Thank you.